Hey guys, how's it going? Today let's do Leetcode 206, reversing a linked list. So problem statement says, given the head of a singly linked list, reverse the list. Then you return the reverse list. So there's three ways that you can do this problem. One is like what I like to call the cheater way. You essentially just put all nodes, into another data structure, such as an array list or a stack. So array list or stack. And if you put everything into a stack, what's going to happen in a stack is this. So you're going to put 1, 2, 3, 4, 5. And since in a stack it's first in, last out, you would just pop everything out one by one, and you can store it into a new linked list that goes like 5, 4, 3, and so on. What you can potentially do otherwise is you can also just put everything in an array list, like just in order, and you can just parse or just go through it backwards. And then store everything in a linked list that way as well. This is a O of n time complexity and O of n space complexity because you loop through n times and use one data structure to store your values. So this problem could be done this way, and technically it is the right solution, but in interviews, it's really not what your interviewer is looking for. With that being said, let's look at the second way. Second way is an iterative way. And in this way, we're gonna loop through the array, and we're gonna switch the arrows. Essentially, we're gonna reverse it as we're looping through it, right? So we have 1, 2, 3, 4, 5. And as we go from this node to this node, we'll swap the what it points to, and we'll talk about how to do that in the example I'm going to show next. The last way is using recursion. Actually, iterative way, let me talk about the time complexity real quick. It's O of n time complexity because you loop through all the nodes, and then it's O of 1 space complexity because you don't use any additional space. For recursion, we'll definitely talk about that as well. I'll write out the codes for iterative and recursive. So that would be O of n time complexity, and it'd be O of n space complexity because recursion has the call stack that's going to be stored. And we'll get more into that detail in the example. Okay, let me just take my eraser, and I'm just going to erase all of these first before we go ahead and do the example. Okay, so first we'll talk about the iterative example. Let me just get rid of all this. Let's do the iterative example. Okay, so let's just say we have our linked list like this: 1, 2, 3, 4, and 5. Okay, and we're trying to ensure that this linked list is reversed. So 2 is going to be pointing to 1, 3 is going to be pointing to 2, and so on. So what two things do we need to know in order to reverse something, right? So say we're at this node right here, right? So say this is our current node that we're on. What do we need to know for 1 to point back to something? So, but like, okay, so previous to 1 is actually 2. So maybe let's use 2 as an example, right? So I'll just say we have 2. What do we need 2 to point to, right? We need 2 to point to 1, right? We need 2 to point to 1. And in order to do that, if we're on the node 2, we need to know what comes right before it, right? So with that keeping in mind, we're going to need a current node and we're going to need a previous node because we need to know what comes before the node that we're on in order to reverse something, right? So in this case, here's what we're going to do. We're going to have current.next, right? I'm just going to write this out. Current.next, because .next is how you parse or go through a linked list, right? So current.next will equal previous, so what comes before it, right? This essentially reverses the node that we're on. So once we have that, then this one is gonna point to previous, right? And when that happens, we're gonna lose this here, let me change the color on this. We're gonna lose this next right here, right? Because current.next or 1.next is now equal to null and not equal to 2. Right? So then what do? Then we have to move previous, right, to equal, we have to move previous. Oh, let me use the red actually. We have to use previous to be current, right? And we have to move current over to the next node, right? Because we're making the next node current, right? So what did we do? Previous, right, was equal to the current node because we have to move that over by 1, and then current was equal to the next node, right? But when we move when we make one.next equal to the previous, we actually lose this reference, right? We know that we lost this reference, so we have to store this reference before we update any variables. So let's store it in a temp node, right? Temporary equals current.next, right? So this is storing current.next before we make any updates. That way, when we want to move this current at the very end, right, to the next node, we could just set this equal to temp. So this is essentially the entirety of your loop and what your algorithm is going to do when you want to reverse a linked list iteratively. So let's run through this example for the next node. So temp will be equal to current.next, right? So current.next right now is equal to 3. So temp is equal to 3. And then current.next is equal to previous, right? So this current is now pointing to previous, which is equal to 1. So current.next is equal to 1. And this is for node 2. Right? And then previous now is equal to current, right? So previous now is equal to 2 because that's, we're going to move everything over 1. And we have to move our current node over by 1 as well. And that's equal to temp, which is equal to 3. So current gets moved over, right, to the new node. And then previous gets moved to current, right? And then we can run through this one more time too. I'll use a different color. So for node 3, for example, current.next is equal to temp, right? So our temp is equal to current.next. So this is equal to 4, right? So we know this is equal to 4. Actually, this is destroyed, right? And so we know the 3.next, right, or current.next is still pointing to 4. So we can store that into temporary. And then now current.next, so this gets, destroyed. So current.next is equal to previous. So let's have a color pointing there, right? So that's equal to now 2. And then previous equals to current. So we move previous over to here, right? And then we move current over to here because we know current is equal to temp. So this is equal to 3. And then current is now equal to 4 because we have to move the node over 1, right? I hope that makes sense. We essentially just keep doing this over and over and over again. We're going to move previous over, then move current over. We're going to get rid of this. And then, 5 points back to 4. This is now current. This is now previous. And then at the very end, what happens is when you move current over, this is null, right? So current is now equal to null. And previous is equal to 5. And we're going to stop our loop when current is equal to null. Like this is our stopping condition. And then we would return previous because previous is now the new head, which is 5, right? So I think this will make more sense when we talk about the code, and let's do that right now. Let me change to my other screen. Okay, so let's do it the iterative way first, right? So first let's have our previous and current nodes. So list node previous, excuse my typing, equals null. And then the current node will start at our first node, right? So current equals head. So what do we want, right? We want our stopping condition, we just talked about it, was that current could not equal to null. So while current is not equal to null, what do we want to do? First, let's set our temporary node so we don't lose our current.next reference, right? Our current.next reference. Next, let's do current.next. So let's set the next pointer, or the pointing, or the pointer from 2 to 3, for example. Let's set that to previous. So 2 would now be pointing to 1. And then we'll move previous over to current. And we'll move current over to the temporary that we stored in order to move on to the next node in the linked list. Sorry, I almost said array list. Then what are we going to do? When we know that once we get to the end, that current will be equal to null, right? And previous will be at the last node. So that would be equal to the head of the new linked list. So return previous should end our algorithm. So let me just submit this real quick and let's see what we get. So let me run this code, make sure no bugs. Okay, and if we submit it, this should be good to go. Okay, great. So let's do the same thing but let's also look at the recursive way of doing it. Okay, so here's how the recursive way works. Let me draw the example real quick. Let me change my color to white. Okay. 1, 2, 3, 4, 5. In general, I think the recursive way is more complicated to understand, so you're gonna have to bear with me here. I will try my best. So we're gonna recursively call the function to reverse, right? So here's what's gonna happen. So first we're gonna call the recursive function on the whole of the linked list, right? Because we're gonna call it at, here, I'll write the call stack here. So we're gonna do reverse, right, of head, right? Which is actually just, okay, let's actually do head.next. And I'll let you know what this is actually doing. So the first one would be reverse.head, right? And in our reverse head function, we're gonna call reverse head.next. So what's actually happening? Let me erase this and write the call stack. So it'll be reverse of 1 to start, right? And that means the entirety of the linked list is going to get reversed. Then we will do this part. Then we will do this part. Then we will do this part. And then lastly, we'll just do 5. So our call stack will look something like this, right? We will have reverse. We'll do reverse of 2. Then we'll do reverse of 3. And then we'll do reverse 4. And then we'll do reverse 5. Okay. So let's see what's actually happening here. When we release this very last node, our base condition, we'll talk about our base case first, will be if head equals null, or head dot next equals null, we will return head. Right? So what this is doing is that, so this condition takes care of if we have an empty linked list, that means head will be equal to null, so we just return nothing. And then we're doing head.next equals to null because, as I talked about before, we're going to be essentially calling the reverse function to the next node, right? When you're on 1, you'll do head.next of 2, then so on and so forth. So when you're at 5 and head.next equals to null, you'll reach the base condition and you'll just return 5. So this reverse 5 will actually return the node 5. Okay, that's important to remember. So now we're at reverse 4, right? So now we're at the 4th node. So I'll use a different color here. So what do we want to happen at the 4th node, right? So at this node, 4 dot next, right? So 4 is the head right now. So head is equal to 4 in this case, right? So 4 dot next, right? So that would be 5 dot next would equal to 4. So this will point to 4, right? So let me write that down. So let's just first do, actually we'll just do list node new head, right? So in this case, our new head would be 5 equals to reverse of head.next. Okay, so this is how all the recursive calls happen, right? And once we got to the end, our new head was equal to 5, right? So this is our new head, so which is the end of the linked list. So now when we go back in the call stack, our normal head will just be 4. So head.next is equal to what? It's equal to itself, right? Because head.next would be 5, and then dot next to that would be actually null, right? Because 5 not pointing to anything. But if you point it to head, 5 would be then pointed to 4, right? And then head.next, so the pointer for 4, we're going to make that equal to null. So that just gets rid of this right here. So we're pointing the next node back to itself, and then we're getting rid of what 4 is pointing to, okay? Then we say return new head, right? And new head in this case is what? New head would just be 5. So we're going to return 5 and 4. Then we go to this call stack, right? So right now we have, so in this call stack, we have 5 is equal to 4, right? Then we go back one more. Actually, that's not what that looks like. I'll show you what that looks like. What it actually looks like is this. 1, 2, or no, I was right the first time. It would just be 5 and then 4, right? And then we'll go to the 3 call stack. The same thing's gonna happen, right? we'll do 3.next.next. We'll make 4 point back to 3. And then we'll make 3.next equals to null, which just gets rid of this right here. So then this would be, and then we return new head. So we return 5, 4, 3, and the current head is now here. So we point 3 back to 2. We get rid of this, and then it would be 5, 4, 3, 2. And then lastly, 1.next.next. So 2 would point back to 1. We get rid of this, and we finish our recursive call. 3, 2, I ran out of room. I'll just say this is 1. You guys get the point, right? So let's again look at one more time what's happening here. So our base condition is that if there's head.next is equal to null, or head is equal to null, we just return the head, right? That's right here. This right here, getting the new head, once we get to the end of the list, right, and we hit our base case, we'll get our new head, which is 5. Then we do head.next.next, right? So once we return this head right here, we move on, and then head.next.next will equal to head. So we're at 5, that gets returned, and then we have head.next, right? Our next call will be at 4, and dot next to that will be 5, and dot next to 5 will be null, but we're setting it back to the head, which if we're at this call stack will point back to itself, right? And then we get do head.next equals to nulls to get rid of this right here. Okay, so that's just important to remember, right? So in a recursive call, you're gonna go all the way down to like the lowest you can go, which is the base condition. So just one node, essentially reverse that, and then do it backwards, right? So you reverse this, then you reverse this, then you reverse this, then you reverse this, and so on. Okay, the picture's a little bit messy, but I think most of you get the point. So now let's go ahead and try to code this out. Let me see what the code looks like. Okay, so let's get rid of this from our iterative solution, and let's see what. Okay, so what do we need first? Let's do the base condition, right? So if head equals null, or we said head.next equals null, we will do return head, right? That it would just return wherever it's at. So if it's at the very end and there's nothing next, it would return the head, or if the linked list is just empty, it would just return head. Let's do list node new head. So new head would be the end of the list, right? So what would return? What would be the beginning of our reverse list? Equals reverse list head.next. So this is the part that loops through the entirety of the linked list. Then we said head.next equals head, and then we would do head.next equals null. So this head.next.next sets the arrow backwards. Essentially that's part of reversing the actual node, and head.next is getting rid of the original pointer, right? The original connection. Then we just return new head, and I think that's it. Let me just make sure there are no, of course there is something here. This is from, okay, this is just extra. Okay, so it was able to reverse the entirety of the linked list, and yeah. So we can see that the difference between the recursive and the iterative, it would just be the O of N call stack. Apart from that, they're both good solutions. I prefer the iterative way, like if I was to normally answer the question, and that's probably what I would go with. But yeah, thanks for watching, guys. I'll catch you later.